Okay, today we're going to start our introduction to optics. So optics is the study of how light is reflected or refracted in order to produce an image. So an image is an optical replica formed by intersecting rays of light. And we're going to do something called a ray diagram where we're going to draw these rays. So first of all, there's two types of images, real and virtual. So real images, those can be projected on a screen, will always appear inverted compared to the object. An image is real when the light rays converge to a point, and the word virtual means not real. So virtual images appear inside or behind a mirror lens. And I'm going to show you what I mean by that because, this is physics. When we do physics, we always have to have a frame of reference. So when we look at the diagram and we establish our frame of reference, we're also going to have a sign convention. And when we do this, ray diagrams are actually going to be simple. But it's establishing our frame of reference, where we measure everything from, and establishing our sign convention, and then it makes it very simple. Okay? So, first of all, let's talk about the law of reflection. So in layman's terms, when you think about the word reflect kind of means to bounce off. And that's what the light rays are doing. They're bouncing off a surface. Because when you have a mirror, and you look at a mirror, the mirror has a silver coating on the back side, and what happens is the rays of light bounce off of it. Okay? But we're going to see that we have different types of mirrors based on their shape. So the law of reflection says when light is reflected from a surface, the angle that the incident, so the word incident means where it's coming from, makes to the normal to the surface is equal to the angle that's reflected. So what does that all mean? Well, first of all, this is going to be a flat or plane mirror. This is the type that you look at in the morning when you're getting ready for school, and it's just flat. So the incident ray, this is where it's coming from, and we use a line and an arrow to represent the ray. And what's the normal? Well, we already learned before in physics that the word normal means perpendicular. So this normal is just a frame of reference, and it's perpendicular to the flat surface of the mirror. So this is the normal, okay? And you see that the normal is perpendicular. So the normal is just a frame of reference in physics for us to measure things. And we're going to use that to measure the angle. So I have my incident ray, and I measure this angle theta from the normal. So I call my incident angle theta I. Okay? So this is just the angle from the normal. And then the refracted ray, this angle here is called theta R. So I stands for incident and R stands for reflected. Reflect, it's bouncing off. Okay, so if I have a flat, polished surface that's really smooth, this is called regular reflection. And it's called regular reflection because if you look at all these incident rays of light, see how they're all equidistant? They're the same distance between them, and they're all parallel. So when they hit this nice, flat, smooth surface, they all bounce off each other, and they're exactly the same. They're all parallel and equidistant from one another. So this is what happens is when we have a flat, plane mirror, we have something called regular reflection. Now, if the surface is bumpy, so let's say you have water, and there's a lake, and there's wind, and it's jagged, or we have something like this irregular surface, this is called diffuse. And it's called diffuse because diffuse means it's like spreading apart. So even though these rays are all coming in, and they're all parallel to one another, because the surface is irregular, they bounce off in different directions. So that's called diffuse reflection. Now, today we're going to start talking about mirrors, and we have 3 different types that we're going to do. So mirrors are used in a lot of things that we don't think about, and they're used in optical devices. They reflect, because again, we're just dealing with light bouncing off surfaces today so that an image can be seen. So the 3 types are plane. Plane means flat. That's the type you look at in the morning. Then we have concave. So concave kind of caves in like a cave. And then we have convex that goes out. So they're used as reflectors of light, and there's a lot of devices that have them in them, like even different types of telescopes might have a mirror inside of it. So based on the shape of its surface, again, it's going to be flat, concave, or convex. So a plane mirror, this is the one we're used to looking at every single day. The image formed by it is right side up, and another word for right side up is erect. It's the same size as the object, and it's as far back in it as it appears. And the only difference is the image is reversed. So the image is the same size, it's the same distance behind it. Now these types of mirrors only produce virtual. And why is it virtual? Because the image is inside the mirror. Now here's a diagram. So here you are in the morning and you're getting ready for school and you're looking into this plane mirror. Now my frame of reference is, I'm going to say how far am I from the object. So my distance from the object, I call that DO for distance of object. And that makes sense, right? How far my image appears, I call that DI for distance of image. Now, if I'm standing 2 feet back from the mirror, my image looks like it's 2 feet back into it, okay? So if I lift up my right hand, then I also see my right hand, but it seems to be reversed, okay? Now let's look at an object in front of a plane mirror. So here's an object, it's a triangle. So here's the left, this one edge appears to be a certain distance. And you see that same edge appears to be a certain distance. Then this part seems to be that same distance, and then this outer edge also seems to be that same distance. So again, important words, incident means where it's coming from. Again, we measure this from the normal, that's our frame of reference, and reflected means the part where it's bouncing off of. Now today we're going to look at our first type of spherical mirror, and spherical means that it's curved. And today we're going to look at concave. So a bowl-like, and then there's different variations. If I have something that's concave, there's different, I can have something that it's curved a little bit or curved a lot. And what we're going to see is that this curvature depends on if I was going to actually complete the circle, you see how much it's curved. Okay? So the shape is a shallow bowl shape, and this type of reflector is used for satellite dishes. Okay? It's used for many different things. So first of all, for all concave, we're going to see that something called the focal length is always half the distance from the center of curvature. And when we go over the homework, I'm going to draw a picture, and I'm going to show you what I mean by the center of curvature. Okay? Which actually just means if I was going to make it into a complete circle, where the center of the circle would be. But I'll show you graphically so you totally understand it. Spherical aberration, this is a defect of some spherically shaped concave mirrors that doesn't allow them to focus light at a certain point. Okay? So the focal length is a distance between the center of the mirror or the lenses of the next chapter, and the focal point. And we're going to look at all this in a diagram in a little bit. So if I'm looking at a concave mirror, my first frame of reference, my first point that I'm always going to draw is I'm going to draw this line here. And that line here is called the principal axis. And the principal axis is important because the principal axis is going to be my frame of reference for something being upright or upside down. So I'm going to use my same sign convention that I always use in this class, and I'm going to call up positive, and I'm going to call down negative, because that's the same sign convention we use in math class. Then my other frame of reference is going to be the mirror itself. Now I'm drawing an up and down line even though it's curved. So here is my mirror, And I'm going to call this direction positive, and I'm going to call this direction negative. And this is for measuring the distance of the object. So this is going to give me a real image, and this negative is going to give me a virtual image. So this is my sign convention for concave. Now if I was, see how this is a circle? If I was to extend this circle like this, here's my focal point. The center of the circle is actually called the center of curvature. So it's actually located a radius from the surface mirror. Now does this make sense that if I extended it, that would be the center of the circle? Okay? And then this focal point is exactly half of the center of curvature. So the center of curvature is 2f, or f is equal to c divided by 2. Now there's 4 cases for these types of mirrors because it depends on where. We use an arrow to represent an object. It depends on where this arrow or object is placed in reference to a few things. The things that it makes a difference is C and F. So is this object placed beyond C? Is it placed on C? Is it placed between C and F? Or is it placed between F and the mirror? So those are my 4 different scenarios. So again, if the object is placed far beyond the center of curvature, so it's beyond C, and this just tells me what's going to happen. So in this case, it'll where the object is going to be formed. And I'm going to give you a handout today that goes over the 4 different scenarios.